A2 Maths, harmonic form. What I'd like you to do is just have a think about this question. What is the maximum value of the expression 3 sine x plus 4 cos x? So just pause, have a think about it, and make sure you've got some reasons for those answers. Okay, so I won't blame you for thinking, well, we know what the maximum value of 3 sine x is, because sine x only goes between 1 and -1. So the maximum value of 3 sine x is going to be 3. And the same idea for cos x. Cos x has got a maximum value of 1, so surely 4 times 1, maximum value of 4 cos x is 1. So therefore, the maximum value of the whole thing is surely 3 plus 4, which equals 7. No, because unfortunately, when this reaches a maximum value of 3, when sine x equals 1, that x value that makes that equal to 1 does not make cos x equal to 1. And the same is the opposite way around. Whatever value makes cos x equal to 1, its maximum value, that x value does not make sine x equal to 1. So what you're looking for is some sort of x value that maximizes the 3 sine x and the 4 cos x. So what I'd like to do is just have a look at the graph of those two. This is the graph of 3 sine x plus 4 cos x. Now what's really interesting about this is when you added these two values together, 3 sine x and 4 cos x, they are separate wave functions. 3 sine x is a single wave, 4 cos x is a single wave, and when you add those two wave functions together, you end up with a new single wave. Also, you'll notice that the maximum value, interestingly, is up here at 5. We'll see why it's 5 and also how we could find it for any equation written in this form, or expression in this case. Okay, so the expression a sine x plus b cos x can be written in this new form. This new form, sometimes called the R form, sometimes called harmonic form, changes two wave functions, so the a sine x and the b cos x, into a new single wave r sine x plus some amount, okay, which we'll call alpha. Now I'll talk a bit about why it's sine, or does it have to be sine, in a second. So the r value, the number on the front, is a number which is always greater than 0. And the alpha value, okay, which is the value you're going to add to your angle to shift it along a bit, is always acute. Again, we'll come back to calculating those two. Right, so if we know that that can be written like that, what I'm allowed to do is write that equals that. That's a nice hint to any sort of exam questions. If they ever say to you, this can be written in this form, what that means is a flash way of making them equal to each other. So a sine x plus b cos x is equal to r sine x plus alpha. Now once we've got that far, what we can do now is we can expand this using our compound angle formulas, our addition rule that we looked at in a previous lesson. So you get your formula book, you can see that you've got sine of a plus b, and sine of a plus b is sine a cos b plus cos a sine b. So we can expand it out using our addition rule. Once we've done that, we can just put the r inside, so we've got those two equations, and we end up with a sine x plus b cos x equals this thing here. Notice I've just done a bit of rejigging. I'll put the alphas at the front, okay, and the cos x and the sine x at the back. And there's a reason for this. The reason is it makes it a little bit easier just to look at equating sine x. And the reason why we equate sine x is that sine x is a variable. X can be lots of different values. Alright, so if that can reach lots of different values, it's very easy to compare it on both sides, and therefore we can equate it. So we can compare sine x to get the coefficients on the front of it. So on the front on this side is just a, and the front on this side is r cos alpha. Now because these two bits are equal to each other, the coefficients must be equal. So a must equal r cos alpha. And the same argument stands for cos x. So cos x is a b on this side, which is its constant coefficient on that side, and its constant coefficient on this side is r sine alpha. So that's the reason why I put them at the front. You didn't have to, it just made it a little bit easier to show you that the A is the same as that and the B is the same as that. Alright, so this is our new set of equations. We've got these two equations come out that if this can be written in this form, then these two facts must be true. Okay, so then we're going to do a bit more work on these two facts. Right, so I know that the A value here is exactly the same as r cos alpha, and the B value here is the same as r sine alpha. What I need to do now is work out what my constants r and alpha actually are. So the first thing I'm going to do is use the trig identity. Now the trig identity I'm going to use is cos squared plus sine squared equals 1. Now if I know that cos squared plus sine squared equals 1, it's always identical to 1. Then what I can do is I can just do a bit of rearranging here, because I can see I've got a cos alpha, I can see I've got a sine alpha, so I'll do a bit of rearranging and I can put them in there and there just to see what happens. So just check you're happy. A divided by r would get me cos alpha, and if I want cos squared, that would be a squared over r squared, so that's where that bit comes from. If I want sine alpha, it would be b over r, and if I want sine squared alpha, it would be b squared over r squared, and that would be equal to 1. What have I done now? I've just times through by r squared to get that equation, and that leads me into this formula just here, that my r value is always the square root of a squared plus b squared. So it's using Pythagoras' theorem just there. And just to look why that's important is if I've ever got an expression or an equation that has this sort of form of two single waves added together, then I know I can rewrite it in this sort of form, and I know the number on the front is always a squared plus b squared square rooted, which is why a minute ago that was 3, that was 4, and that ended up being 5, because 3 squared plus 4 squared square rooted is 5. Right, so let's see if we can work out now what the alpha is. So we've used our first trig identity there, so let's look at the other trig identity we know. Sine alpha over cos alpha equals tan alpha. Now if I use this trig identity, same idea as before, sine alpha is b over r, cos alpha is a over r. I can substitute both of those in. I can rewrite this fraction here by times in top and bottom by r. Okay, so it's an equivalent fraction. That's why you haven't taken an r over that side. So I've just times top and bottom by r, and I've got tan alpha equals b over a. And more importantly, alpha equals tan to the minus 1, b over a. Right, this is very important. It's very important to make sure that when you're rearranging, you're always considering which one is your sine attached to and which one is your cos attached to. So in this case, we knew that tan is sine over cos, so it's always the sine bit, in this case b, and the cos bit a. Sometimes that might be the other way around. So you need to be very careful, depending on which addition rule you used, these two may be the other way around. I'll refer back to that in a second when we see another example. So I've got two formulas now. I can work out the r value and I can work out the alpha value. And you need to make sure that you know how to at least get to those two, even if you've forgotten them in the exam. You know how to reform them. Right, so I've got an expression, a sine x plus b cos x, and it can be written in any of these forms. So a minute ago, I said it can be written in that form. And I said I'll tell you why it's sine. It doesn't have to be. In fact, it could be cos. There's no reason why not. And also, it doesn't have to be plus alpha. It could have been minus alpha. So it could be like that, or it could be the cos versions. Now the truth is the examiner is most likely to tell you which one it is, but if he doesn't, then you can still pick any one you like. Sometimes they work out quite nice, depends on whether it's plus or minus alpha, or whether it's sine or cos, and it depends which addition formula you try to use. And I've already mentioned that once you write them in a single form, it's either called harmonic form or the R form for obvious reasons. Right, so let's have a look at a question. So it's the same question we did a minute ago. We saw the graph of it. Let's see if we can get the equation of that original graph. So I want to express 3 cos theta plus 4 sine theta in a single wave function. Talk about why it's important to make sure it goes into a single wave function later on, what the uses of it is. But that's what I want to do first of all. So first thing I'm going to look at, if you've got it down in your notebooks, so the first thing I want to look at is we want to write it in that form so we can make it equal. Notice this is different to before. This one's a cos with a minus. And the reason why the examiner may have picked that is because he knew that if you've got cos theta minus alpha, it's going to lead to a nice plus in the middle because that addition rule is a plus. I'll show you what I mean. It's that formula just there, that cos A plus B, sorry, A minus B is cos theta cos alpha plus sine theta sine alpha. Okay. So once we've got that form, what we can do now is we can use our two formulas. So we know if we equate, we're going to get 3r cos alpha, if I equate the two cos thetas, and the sine thetas, I get 4 and I get r sine theta, excuse me, r sine alpha just there. Okay, making sure that you equate the constants, the coefficients, so it's the alpha values that you're pulling out. Okay. What can I do then? Well, I know the r value is just going to be the square root of the a's. I don't have to keep writing down the whole sine squared plus cos squared equals 1 part, but that's where it comes from. So my r equals 5. You should always make sure that you get that in the exam. Even if you've forgotten how to get everything else, whenever you see one of these questions in the exam, it's very easy just to square, square, square root and make sure you picked up the marks for the r value. Right, what about the tan value? Now this is what I was talking about a minute ago. Make sure you pick the right one. So the tan is the sine over the cos. In this case, it's going to be the 4 over 3 because it's sine over cos. Right, you sometimes need to be careful because people accidentally use the theta values. Now in this case, the theta values would be the same, but sometimes the theta value is the opposite. Okay. I'll mention that in a minute. So there we go, tan to the minus 1, 4 over 3, because it's sine over cos, 4 over 3, and that's going to get us 53.1. Okay, so 53.1 degrees. So that means that 3 cos theta plus 4 sine theta can be expressed as a single wave function, 5 cos theta minus 53.1. And if you talk about transformations, okay, we can see that it's been stretched by scale factor 5, which is why its maximum is 5, and it's been translated across the x-axis to 53.1. So the whole graph has moved across and starts at 53.1. Okay, so I'll give you chances to get the next question down in your notebook. You might want to have a go at it yourself. The only subtle difference between this and the previous one is the fact that now you've got an equation and we're making it equal to 2. If it's on the interval of 0 to 2 pi. Just want to mention one thing. Sometimes you get these questions and you've already seen them. Okay, so if I had something like this, 6 sine theta minus 5 cos theta. So if I got that exact same question, but the equation said it's equal to 0, that is a slightly different question, because what you should be doing in this case is thinking, oh, I can know what to do. If I take that over that side, I'm going to get 6 sine theta, and that's going to be equal to 5 cos theta. There we go. And if that is the case, now what I can do is I can divide everything by cos, and so I end up with 6 tan theta equals 5. And then I can divide by 6 and solve it. Now the difference is this time it's a 2. So the moment it's a 2, you cannot use that technique. That technique only works if you have an equation equal to 0. So in this case, I'm going to have to use a different technique. Now I couldn't solve it before because I didn't know how to do harmonic form, but now I do. So what I'm going to do, once I finish rubbing all this out, there we go. So what I'm going to do is start off by changing this part just here. Let's put my highlighter back on. There we go. Doing this part just here into harmonic form. Notice it doesn't tell you what to use, so that means I'm allowed to use anything I like. What I'm going to make sure is that I pick an addition formula with a minus in the middle. I also notice I'm in radians, not that that makes any difference. My answers are probably going to be decimals under, for acute angles, underneath half pi. So notice I've picked sine minus, and the reason why I'm picking sine minus is because when I use my addition formulas, which you'll see now, I end up with a minus sign in the middle, and that just makes my life easy. It doesn't matter if you pick a different one. If I'd put sine with a plus, then I'll have minus 5 equals plus r cos theta. It doesn't make any difference at all. Okay, you just need to be more careful with the negatives. But it could be any of the 4 that we showed you earlier on. Right, so I've got 6 sine theta minus 5 cos theta equals r sine theta cos alpha minus r cos theta sine alpha. Right, so now I can do the same as before. Compare the coefficients, I can compare the cos and I can compare the sine. So there's my cos function. Notice I'm ignoring the minus because it's on front of both of them. I could have put a minus on the front of both and it will cancel out straight away. It doesn't matter. Also, when I come to do my r value, I can ignore the minus altogether because it's going to get squared. So I'll get a 5, I get the r sine alpha, and for the sine part, I get 6 and I get r cos alpha. So I've got those two parts just there. Okay, so my r equals the square root of 6 squared plus 5 squared, and that's what I referred to a minute ago when I said it doesn't matter about the minus because it's getting squared. And so I end up with root 61. Right, so what can I do now? I need to find the tan function. And this is what I was referring to a minute ago. So I'll explain it again. If I'm looking for tan, I do 5 over 6. Now do 5 over 6 because the sine alpha is 5, cos alpha is 6, so sine over cos is where tan comes from. Now the mistake people often make is they look back at the original equation. Now look at the original equation. If I did sine over cos there, it's wrong because it's 6 over 5. That's different to this one. So it's absolutely vital that you do not look at the original function when you're doing your alpha value. You always make sure that you write out your sine alpha and cos alpha because they're the ones that go into that tan to the minus 1 function. Okay, so sine alpha is 5, cos alpha is 6, and it's sine over cos, so it's 5 over 6. So that gives me an alpha value of 0.695. Just be aware it's in radians, so don't write something silly in degrees because it wants it in radians. And so that means I can express 6 sine theta minus 5 cos theta in that form. Now, why would I want it in that form? Now, the reason why you want it in that form is because there was no way of solving this equation before we actually rewrote it in this form. You could not solve that equation using any of the trig identities I had before. It doesn't work with cos and sine because if you thought, I know what I'm going to do, I'm going to divide everything by cos. Yes, you get 6 tan theta. Yes, you get minus 5 because the cos theta and the cos theta cancel out. But that equals 2 over cos theta, which doesn't help. When it was 0, it was fine. But being 2, it's no help at all. So you have to have harmonic form to solve it. Let's have a look at how to do that. So I'm going to rewrite that equation equaling 2. I know that is equivalent to that. So if I'm looking for when that equals 2, I just solve that equal to 2. Right, what can I do then? I'll solve it the same way as you practiced earlier on in other lessons. I can divide by root 61. There we go. I can then use sine to the minus 1, thinking about my interval. Okay, and in that interval, I'm looking for theta minus 0.695. Not theta, but theta minus 0.695. So I'll consider all the values between these two. So that's going to be 0.259, 2.883. Okay. Then once I've got those values, I'm going to add 0.695 to them. And there I go. I got my two values. And don't forget, you can check those back into the original equation. So I'd like you to have a go at just doing that. Try doing 6 sine of 0.954, take away 5 cos of 0.954. The answer is not going to be exactly 2, but it should be close, okay, because these are rounded figures. Okay, so we looked at 2 questions there. We looked at just being able to write it from an expression, but we've also looked at how to write it to solve an equation. Okay, so there's 2. That's the reason why it's important to be able to write it in harmonic form, because it helps us to be able to solve it. And there's another reason why as well. I'd like to think about the maximum value of 6 sine x minus 5 cos x. So that's the question we started the lesson off on. What's the maximum value? And again, back to the start of the lesson, it's not as simple as going, oh, well, 6 is the maximum value of that, 5 is the maximum value of that, so it's 6 take away 5 is going to be 1. Okay, it's nothing to do with that. It's to do with the fact that you need to write that as a single wave. Now we just did that. That previous question, we've already done that one. It was root 61 sine x minus 0.695. Now you've written it as a single function. Why is root 61 the maximum? Because this part just here is never going to be greater than 1. And because sine x minus 0.695 radians is never going to be greater than 1, this is never going to be greater than root 61. So the R value finds the maximum. If you're asked to find the minimum, what would you do? You would say that the sine x minus 0.695 is minus 1. It's never going to get smaller than minus 1, so therefore the minimum value of it is minus root 61. Okay, so this function here ranges between root 61 and minus root 61. When does that actually occur? So sometimes you might get asked that. When is the maximum value of the expression occurring? So what x value would you have to put in? So you know this fact just here. You know that the maximum value of root 61, when does that occur? When is it its maximum? So what x value would it be? And the maximum value is when this sine x minus 0.695 is equal to 1. So what does that mean then? Well, we can take the sign over the side. Sine to the minus 1 of 1. X minus that is that. So therefore, it reaches its maximum value of x equals 2.27. When x equals 2.27, that will reach its maximum value. And I've often seen the examiners apply these to real life problems, things like wave functions like on the coast, when is the maximum tide, those types of questions, and the x value would represent the time of maximum tide. So they can easily set these as an applied maths problem. You just have to use the harmonic form to help solve that. Okay, so there's a lot of questions there, you'll notice. And the reason why there's a lot of questions is because you've got some that are just practicing writing it in harmonic form, some that are using the harmonic form to solve certain equations, and again, some that might have to solve real life problems. So don't be lazy. Do make sure that you're having a go at most of those, if not all of them, to get nice and solid at practicing harmonic form. Okay, good luck and see you next lesson.